Welcome to this section on second generation materials, and in particular here we're going to be looking at them from a life cycle assessment perspective. So we know that we use way too much clothing and too many fibres. We know that there is an imperative to be able to tap that resource stream so that we can make our new fibres from old garments. But we also want to make sure that while we do that, we don't go sort of like creating more pollution and more impacts by using too much energy, water, etc. in the process of recovering these materials. And life cycle assessment is a very useful tool in this respect because it is sort of the science behind sustainability. It helps us to quantify what impacts there are and where they lie in the life cycle of a product. So life cycle assessment is a method to calculate impacts, and it will be looking at where the impacts lie in terms of whether they are polluting water, using up too much electricity, consuming too many non-renewable resources, etc., etc. So one thing that scores quite well in life cycle assessments is using waste resources as the starting point for new products. Because LCA measures the impacts involved in extracting and transforming the raw materials, and those will be calculated as spread out over the many lives of the materials in these different products. So these second generation materials can come from existing textiles, like the old jeans that we were talking about before, that can be chopped up, pulled into new fibres and then respun to make new textiles. A company that is doing this particularly well is a company called Recover, and they have been quite exemplary in the way that they are collecting different textiles and then sorting them by colour so that they can reduce the impacts that will be associated with dyeing, because the colour is already included in the material from the start of the recycling process. It's also possible to make regenerated cellulose fibres, like we've also talked about, that will look and feel a lot like viscose. But instead of using trees, like in the viscose process, the cellulose is recovered from waste textiles like cotton or other cellulosic fibres. It isn't possible to chemically recycle cotton into cotton, but the chemical recycling process will produce a new fibre that will be engineered to serve our needs with properties like antibacterial properties, or even giving the fibre a new shape so that it can respond to different types of properties. Second generation materials can be made from this waste textiles, but it can also be made from other streams of waste. So for example, one approach in terms of using waste to make new textiles, which is very exciting, is the production of new textiles from agricultural byproducts. So in the production of food, stalks, leaves and other parts of the vegetables that are being made will be left aside and they won't have any use. But these materials will contain high levels of cellulose, which can, in the right process, be recovered to be made into textiles. So an example of this is this material, which is called Pinatex, which is made from the leaves and stalks of pineapple production. So here we've got a type of mechanical recycling process, really, where the fibres are extracted from the waste, from the agricultural byproduct, and then treated so that they can be made into this non-woven material. One of the very exciting things about this non-woven fabric is that because it's not being made and spun into a yarn, a lot of the steps that would be using quite a lot of electricity are completely bypassed, and we get from the waste, so pineapple leaves and stalks, to a material in as little steps as possible, so that we can have a material that scores quite well in terms of its life cycle assessment. Another example of a waste product from the food industry that can be made into a textile is orange fibre here. As the name sort of indicates, it is made from the waste from the orange industry. So all the peels that are recovered after the oranges have been made into orange juice contain quite a lot of cellulose, and that cellulose can be extracted in a chemical recycling process so that it can be made into this material which looks almost exactly like a virgin fibre. So life cycle assessment gives us the tools to quantify the impacts of a production process, of a product, all over the life cycle. So this means that we are able to understand better how second generation materials, whether they come from waste textiles and garments or from agricultural byproducts, can score well, and how we are actually gaining in terms of the impacts associated with the new products. It also means that we can keep an eye on all the other places where impacts might be happening, understand how we can make these new materials from waste, but also reduce the water and energy that is used in this process.